Ik kijk gewoon naar u. Hè. De camera mag ik negeren of moet dat ook nog een beetje...
Kijk gewoon naar mij. Moet hij lachen, moet hij vies kijken, moet hij
Nee,
doen.
maar staan er 4, zie ik. Dus het is ook een beetje de vraag.
Al de 7 al er toch uit, dus dat moet er niet meer.
Ja.
Welcome to the podcast of Indisruptive and Friends. The podcast where we play with industry and tech peers between candy, espresso and soda. And the necessary small talk, merciless trashing or cashing mantras, biases and trends for the next coming years. This podcast is sponsored today by our friends from Industrial Fairs, organizing 6 techno-industrial events where tomorrow's technology is on display today. Visit industrialfairs.com for our next events. Live from Abyss in Kortrijk Expo, our guest today is Jan Van Nylen from ZF Wind Power. Jan, who are you and what are you doing?
Well, I'm responsible for operational excellence in the business unit ZF Wind Power of the ZF Group. ZF Wind Power is a business unit in the industrial division of ZF. ZF is a leading tier 1 automotive supplier, but the industry division houses everything that has nothing to do with automotive, but still has gears in it, because that's the core business or the heritage of the ZF Group. And we make transmissions for wind turbines.
Now, Jan, if you're talking about transmissions for wind turbines, who are your customers then?
Our customers are the OEMs of the wind turbines. Biggest in Europe is Vestas, the most known. It's our biggest customer. But you have Siemens Gamesa, you have GE, all people that are building wind farms for electricity companies like ENGIE, etc.
How is your? I can imagine that I hear some names like Gamesa, for example. I can imagine you're living in a competitive environment. That
Yes.
It's not only the accuracy and the right compliance to of the product is necessary, but I suppose also the price matters.
Indeed. If you know that in the past 2 years, 80% of all wind turbines are constructed or are placed in China, you know that China has a big part of the market and is driving our industry.
You have suppliers? Are there? You have competition in China?
Well, yes, we do, and no, we don't. In a sense, in China itself, the market is protected, and only Chinese OEMs and Chinese suppliers really make a chance. ZF we have a production facility in China, but it's really hard to get a part of the market share there,
Even having a production plant.
even if you have a production plant.
Okay. Now, you already did your talk on Abyss, I suppose. Any thoughts, any ideas when you entered Abyss? Is it your first time that you visit Abyss?
No, this is my third time. I was here last year, and a couple of years ago, I also visited for the first time. Yeah.
And what are your impressions? Any idea about how the atmosphere and the ecosystem is changing? Have you seen things that you say, I didn't know that, or that is a new insight? Have you learned anything?
Well, it's a good venue to meet a lot of people in one day or at one location. So there are a number of companies here that are familiar to us, where we've discussed previous use cases. Suppliers of us in our IoT story are here, so it's good to meet up with people, but it's also good to see new things evolving.
Happy to hear that, and hoping that we can bring that in our next editions. Now, about your talk, if anybody should ask you when you're in a pub, I had a talk on Abyss, and you have to explain it to somebody in a pub. What was your talk about? How would you formulate it?
Well, what I brought to the audience here was some clear examples of real use cases in our company, how we use data to influence our production processes in 3 clear examples. So I wanted to be tangible, not just about tech, mixed audience maybe, but my goal or what I like most is that people, and it happened today, so I call that mission success, that people come to me and say, I understand. I understood what you were talking about. Thanks. It was interesting rather than bringing a lot of technology terms to the floor. So I really put emphasis on first making people understand what it is we do, how we do it, and why data is important to optimize what we do.
If people are triggered from your talk and the reactions you gave there, is it more out of insights on modus operandi as strategy more than effectively the technological tool solution that you that people are asking you things about?
Well, I had to make a choice.
Yeah.
Obviously, with an audience like this, you will have a lot of people that want to understand the technical details. But I personally also like it when in a pub or with my mother, I can explain what it is that we do, and I try to bring it in a comprehensive manner as a start. The tech guys will come later and ask me, yeah, good now that I know what you do, but
Yeah.
how did you do it?
Yeah.
So in my talk also showed a bit the details behind on how it's done, but I didn't elaborate on that. Like I said, it is a choice that I made, and I'm glad I made the choice
Yeah.
I did.
If I um, if I recall in our pre-discussion before the podcast started, um, you told me that in fact you want to explain how you solve problems with digital tools. If I understood you well, you gave three issues, three challenges, three examples of certain issues you wanted to modernize, digitize. Can you give us some more details about that?
Yeah, indeed. I had three examples in the length of our process. So I started with where our steel, our gears that we produce, were in a heat treatment process, and then later on the grinding. And we had two examples there where one from the data from the entire process chain, we are able to steer, optimize the heat treatment because that leads us to a reduction of gas consumption, which is financially interesting, but also CO2 emission wise an interesting topic. We are a green company in a green sector, so we want to there also be leading in showing that we care about the
So
footprint of our
that's
process.
a green flag on sustainability and cost optimization for that
Yeah.
first example.
Yes, indeed. So both cost, but also CO2 reduction,
Yeah.
and consecutively with this information of what the heat treatment has done, how hard the material is, optimize the gear grinding
The
process.
gear?
The gear grinding, so
Yeah.
the finishing step of producing the
Okay.
gear,
Yeah.
where it is crucial that you make a certain gear profile, a patented profile, which is our strength. But you cannot take away too much material because then you lose the material properties or the hardness.
Mm-hmm.
By combining the information, we can optimize both processes. While in my example on the gear grinding, it's about cost reduction by avoiding scrap cost, waste in your process, or a gear that you have produced but is not usable anymore that you have to throw away.
So it's scrap reduction for a part, and it's product improvements or
Well,
quality
quality secure.
quality securing.
Yeah,
Yeah. Yeah.
maybe a bit more detail, but the thing is with the heat treatment, you have a certain layer of carbon in your surface, but you cannot measure that. At least there's one way to measure it. That's to destroy the part, cut it in half, and then
Yeah.
you can see.
That's not advisory. Yeah.
No, that's not advisory. So what we did in the past is to build in a lot of securities, basically over processing, putting in too much carbon, having it too long in the heat treatment to be on the safe side. And then we took the assumption, okay, we have a threshold, we have a boundary to work with, everything will be okay. What we did now is that by taking the data and sending it through our theoretical model, we know for each part that we are good, yes or no. So it's still not a measurement, but it's an educated guess based on the data of the processes we have, such that our quality guy can sleep well at night and say the parts I checked today are all good.
How do I see that, Jan? Is that uh, it's it's a tool with a dashboard?
Yeah.
It's not a co-pilot or an agent who says, in that sense, do this now, or who takes his own decisions.
Well, it's both a dashboard for the process engineer to monitor the process and to look for room for improvement, but it's also a dialogue system with the operator on the machine. In our business, the gear grinding operator, he really has to know his business. He's not just pushing buttons of a program that is on the machine installed by the process engineer. He has to do some measurements and tune the process for a specific part. So he has to make changes to the program. What we implemented is a dialogue with the operator and a check on a server, such that the settings he puts into the machine are now verified, and there is feedback to the operator.
He's like a digital jet fighter.
Yeah.
He puts the instructions in. He's in control. As long as everything goes okay, he gets warnings, and then he has to make his own decisions.
Yes.
He still has to make his own decisions.
He still has to make his own decisions. So we're monitoring the decisions he's taking. If they are in line with what our process engineering expects, he gets a green flag. Everything's okay. If it's not in line with what we thought it would be, he still can take the decision. I know it's not in the usual boundaries, but I have to do this to save the part or to make a good part here. But that information is also stored, such that if he was wrong in the end and the part is still bad, we can enter a dialogue with him and see what information led him to take the decision, to overrule the decision.
Where he took the wrong decision.
Yeah,
just
wrong
as,
decision.
as a learn as a
Yeah, indeed.
as a learning traject,
or
to
indicating
challenge him.
for us that he needs further training, or he's lacking some information. If he overruled the decision and the part was still okay, obviously, perfect. He saved a good part from being thrown away.
Okay. And then you had a third project?
Yeah. Our third project is in the assembly process, where we put it all together, where we again use information from the parts that we are putting together, dimensional information, quality information, to optimize the way he puts it together. Previously, 2 years ago, an assembly operator just took the parts as it was convenient to him, like you and I would do. The part that is closest you take first, and then gradually you work your way back. What we implemented is that based on the data, we do a calculation of what is the best combination of all the parts that he's to assemble in one subcomponent. So he no longer has the freedom to take what he likes best, or what is closest to him. We now inform him what is the best combination, and this allows us to get a higher torque output, basically to make our product 10% better.
Efficient, more
free.
Efficient, or
yeah, better,
or really better.
Better in the
By
sense
better assembling, or
yeah, our product or the big driver is how much torque our product can process.
Yeah.
Because the blades are getting bigger, the forces are getting bigger. We design products for a certain load, but by giving the operator the freedom and the tolerance chain of all the components, it could be that some of the components have a higher load than others. They will act as a weakest link.
So the way and the ordering, or from how components are assembled into, can have can influence the torque.
Yeah, we're talking about minimal fractions of a millimeter shift of component, but because of the forces and the torque values nowadays are so high, this starts to matter.
It's exponential.
It's exponential. We have a lifetime of our product of 20 years. A wind turbine has to be there for 20 or more years. So although it seems like not top technology. It's just gears. The finishing and the specifications of it all really is cutting edge, and is getting even more stringent every day because of the turbines growing. So yes, indeed, what the operator does, and in the tolerance chain. So the operator doesn't make a mistake, but the design is such that there he creates some kind of fluctuation which we have to incorporate in our specifications towards our customer. So this is statistics. This can happen. So I refer to 10% increase. Yeah, what we had to say, okay, we design a gearbox for a certain customer specification, but we had to over design it by 10% such that in the worst case
Mm-hmm.
scenario, the product still is according to the specification of the customer.
Yeah.
So we're over designing, making it more robust than it actually should be, meaning extra costs. Now, by doing this calculation on with the data we have, we can create a better output. We can optimize this such that the safety factor can be taken away, because basically now we have control of what is happening, and therefore we save design costs, and we don't have to over design,
Yeah.
reducing
In
the cost.
fact, when people are talking about digital transformation and the use of digital tools, the main goal is efficiency, OEE, KPIs like OEE, cost optimization, resource optimization, whatever, efficiency in general. Are there in your company also challenges or maybe opportunities for the use of digital tools that lead to, for example, real product innovation or maybe a new business model?
Yes, but that's not what I do in our company. I am responsible for the digitalization in the processes, but
Okay.
I have colleagues that are responsible for the digitalization of our products. And there we have now equipped our gearboxes with sensors, so we collect data from our products in the field, and this allows us to make predictions about the remaining lifetime of our products, knowing
Predictive
which
maintenance,
components will be
monitoring,
yeah,
things
indeed.
like that.
So
Yeah.
we're offering now service models, service packages to our customers, or basically the end customer, the customer of our customer, the electricity companies, etc., such that we, for instance, guarantee uptime or make spare parts available to them. Because time is essence. When a wind turbine stops,
Yeah.
literally
You
costs a
lose a
lot
lot of
of
money.
lose
Yeah.
a lot of money. So a reduction of the downtime can be achieved by making good predictions about which components are most likely to fail. Obviously, not many fail, but at least there is a theoretical model now where we say, okay, customer, if you pay us a certain, very
A
limited
fee
monthly fee
as a service.
as
Yeah.
a service, we guarantee that you have a short lead time on these and these components because these are most likely to fail. And that is new business we have. That's a new revenue stream that we've developed in the past years. Indeed.
Maybe final question, Jan. In something a span of 5 years, where do you see as a digitally performing company? Uh, where do you see ZF evolving, or what do you think are the next gen challenges which you're occupied with?
I, what I want to achieve, or what we want to achieve, is to take a step into predicting or being proactive. The examples I gave you is actually retroactive. It is to avoid problems, quality issues, but it's taking the data that is available already and using that in a use case. So we're not yet predicting on our shop floor in the processes what is to happen. There's a lot of room still for further optimization, to to adhere new properties to our gear grinding or our milling processes, to avoid quality issues with when we, for instance, see a material issue. You can throw away the part, or you can make sure that the issue is where you take away material anyhow.
Mhm.
So that it's along that kind of things that we are developing or thinking of. And the next big step that we're also taking will be automation, uh, real automation with a production line where the parts go from one machine to the other, or incorporated in one big machine.
And you talking
Um,
about general automation, robotization, things like that,
yeah,
other production lines,
yeah,
autonomous systems, AGVs, things like that,
yeah,
warehouse automation.
yeah,
So in fact, you're doing the other way around. Some people start to automate and then digitize. You
yeah,
have that also. So you started first to digitize and then really
yeah.
to robotize and automate. If I catch
Yeah,
catch your drift.
that is true.
Yeah.
Partly driven by the fact that for a long time, robotization, robotization, sorry, was not an option, or not perceived as an option, because everything we make is very big.
It's
Um,
very big, and I suppose it's, if I'm correct, it's high mix, low volume,
no, we it's low volume, but
slow
also
volume,
low mix. So we don't
and
have
low
any.
mix.
Yeah.
Okay, so it's
Uh,
kind of modular.
Why it's modular. The biggest challenge we have there is our product is constantly evolving.
Yeah.
So the changes to the process are, despite being low volume and low mix, there are still quite a lot of process changes that we
So
have
there
to
is a
do.
product complexity who evolves, but it's not that you're making 1,001 variations
No,
on the product. You have
no,
less choices, but your product becomes even more complex
yeah.
as we're growing into the years. Okay, Jan, I think maybe as a closer, can people follow you on LinkedIn, or do you have publications which you post regularly, or do you have a newsletter? Can they follow you anywhere?
Well, yes, on LinkedIn, but I'm not very active on posting or publishing things
Yes,
that we're
as you
doing.
can see, listeners and watchers, Jan is busy with the company and his challenges. He's not busy with his ego on LinkedIn publishing things. It's a pity, of course, but you have because you have a lot of knowledge. Jan Van Nylen, thank you very much, and hoping to see you again in the next edition of Abyss. And for the public watching and listening, thank you very much for your attention, and see you back in the next podcast. Thank you.